right? So now we continue with the pressure in liquids. The weight of the liquid causes pressure in the container. Okay, so this means, if you can see, this the red arrow color. Okay, this is stand for the pressure. Okay, so this pressure is produced is due to the weight of the liquid. Okay, it also causes pressure on any object in the liquid. So let's say you have the object, this is the dams, okay, this is the ship, and this is the ground. All of it we have the pressure, okay, due to the liquid weight. Okay, let us study the properties of the liquid. Okay, number one, so we say that pressure acts in all directions. Okay, the liquid push on all surfaces it is in contact with. Okay, for a submarine, so this means that the pressure is being exerted, okay, equally on all parts of the hull. Hull means the body of the submarine. So this is the submarine. Okay, as you can see, this is the pressure produced from the liquid. Okay, they produce in all direction. Okay, up, down, left and right. Okay, all direction. That's why it say pressure acts in all direction. Okay, let's move on. Okay, pressure increases with depth, as I mentioned earlier. Okay, the more deeper, okay, the more deeper, something like this. Okay, the more deeper the liquid, the greater the weight above, and so the higher the pressure, the bigger the pressure. Okay, as you can see here, this is the container. Okay, let's say you make 3 holes. Okay, 3 hole, 1, 2, 3. Okay, if compare hole number 1 and hole number 3, okay, this is the liquids that coming out from the container. Okay, the distance, okay, where the liquids comes out, okay, if compared to the hole 1 and hole number 3 here, the hole number 3 here, the distance where the liquid come out is much bigger compared to the hole number 1. Okay, this is due to the higher pressure at the bottom and small pressure at the top. Okay, that's the reason. Okay, this is why dams are built with a taper towards a thicker base. Okay, as I mentioned just now, this is the dam. Okay, if you look at the top here, okay, so top here will be, the area here will be smaller. Okay, here will be the bigger. Okay, so why, as I mentioned just now earlier, okay, at the bottom the pressure is much bigger compared to the top one. Okay, so this is because, okay, if you build, let's say you build the bottom here, smaller area, so this pressure, you know, this pressure is bigger. This pressure will push the wall and make it collapse. So that's why they built the bottom here much bigger compared to the top here. Okay, the main reason because, but okay, I repeat again, the main reason is the bottom here, the pressure, you know, the deeper the liquid, the depth of the liquid, the higher the pressure. So which means the force is stronger here. Okay, the pressure is strong here to push the wall. Okay, if the force is strong, so if this structure is built small, okay, at the bottom here, the pressure will push, the strong force will push the wall and make it collapse. Okay, so that's why it needs to build at the bottom here bigger compared to the top here. Okay, so the next one here, pressure depends upon the density of the liquid. So the more dense a liquid, the higher the pressure at any given depth. Okay, now we go to the next one. Okay, pressure doesn't depend upon the shape of the container. Okay, the pressure at any particular depth is the same whatever the shape or width of the container. Okay, let's see the example here. Okay, we have different shape of container, so that's why they all will have the same level of liquid, same level of pressure, because pressure doesn't depend upon the shape of the container. Okay.